You are certainly not unfamiliar with silicon carbide. As one of the typical materials of semiconductors, its importance is self-evident. In recent years, driven by market demand for chip, new energy vehicles and photovoltaics, the global silicon carbide market is growing rapidly. According to the statistics of Yole, a French market research agency, the market size of silicon carbide power devices in 2021 was about $1 billion, and it is expected to exceed $3.7 billion by 2025. China emerging industries such as 5G communications and electric vehicles are booming. Driven by demand, China's entire silicon carbide industry chain is making rapid breakthroughs. Many companies have invested in the silicon carbide meal industry, and some have made a lot of achievements in this field. What is the importance of silicon carbide and why are so many companies investing in this industry? What breakthroughs has this made in the field of silicon carbide? Hi everyone, welcome to my channel. First, let's take a look at the material silicon carbide. The development of the semiconductor industry has gone through three stages. The first generation of semiconductor materials is represented by silicon. In the second generation, gallium arsenide was widely used. The third generation is represented by silicon carbide, compared with the previous two generations of product performance advantages. Silicon carbide, also known as moissanite, is a rare mineral that also exists in nature. In industry, quartz sand, petroleum coke, or coal coke, and wood chips are used as raw materials to smelt through resistance furnaces at high temperature. Silicon carbide is a core material in important fields such as satellite communications, high-voltage power transmission and transformation, rail transit, electric vehicles, and communication base stations, especially in the fields of aerospace and national defense. In the field of chips, silicon carbide, as a typical representative of the third-generation semiconductor materials, is also one of the most mature and widely used semiconductor materials in terms of crystal production technology in device manufacturing. It is an ideal semiconductor material for high temperature, high frequency, radiation resistance, and high power applications. Because silicon carbide power devices can significantly reduce the energy consumption of electronic equipment, it is also known as green energy devices that drive the new energy revolution. Thus, silicon carbide for 5G communications, electric vehicles, semiconductor industry is crucial. Therefore, many Chinese enterprises have invested in this field. Recently, lithium battery companies, communication companies, and major vehicle manufacturers have been focusing on silicon carbide and frequently invested in related startup companies. On June 29, TankBlue underwent an industrial and commercial change, adding new shareholders CATL and so on. Among them, CATL subscribed for a capital contribution of 150 million yuan, and the final beneficiary shares were 6.82%. According to the data, TankBlue is a company specializing in the R&D, production and sales of third-generation semiconductor silicon carbide substrates. At present, TankBlue supplies substrates in bulk to more than 60 Chinese scientific research institutions, and exports to more than 20 countries and regions such as Europe, the United States and Japan. In addition, TYCC, as an upstart of silicon carbide epitaxial wafers, is unanimously favored by CATL, BYD, Huawei, and SAIC. On June 13, TYCC had an industrial and commercial change, adding new shareholders BYD and so on. Previously, Hubble Investment, a subsidiary of Huawei, has invested in it. There are also many other companies invest in the silicon carbide industry. Why do companies choose to invest in silicon carbide? Just because silicon carbide performs so well? Silicon carbide power devices have significant performance advantages in the field of new energy vehicles. For example, in the main inverter, the use of silicon carbide MOSFET can improve system efficiency by about 5%. As a result, OEMs have two choices. One is to use the same battery capacity, and the cruising range can be increased by 5%. The other is to design the same cruising range, but the battery capacity can be reduced by 5%. Another factor is cost. The current price of silicon carbide power devices is indeed still higher than that of silicon devices, but advantages such as higher efficiency of silicon carbide devices may make the price of the entire system lower than that of silicon solutions. In the photovoltaic industry, after using silicon carbide, the conversion efficiency of the photovoltaic inverter system can be increased from 96% to more than 99%, the energy loss can be reduced by more than 30%, and the power density can be increased by 50%. It can significantly improve the service life of the circulating equipment, reduce the system volume and save 10% of the system cost. In China, in addition to some of the above-mentioned companies, there are still many companies promoting the development and improvement of China's silicon carbide industry chain. For example, one of Star Power's key projects is to promote the application of silicon carbide power devices in new energy vehicles. As early as 2020, Star Semiconductor's automotive-grade silicon carbide modules have been designated as projects by OEMs obtaining a number of domestic and foreign new energy vehicle main motor controller projects. In the field of substrate wafers and epitaxial wafers upstream of silicon carbide, Chinese companies have also made rapid progress. Rosehau Technology recently disclosed that it has 280 crystal growth furnaces in place. It is expected to produce 500 to 1,000 silicon carbide substrate wafers in July, 1,000 to 2,000 wafers in August, and a monthly production capacity of 5,000 wafers by the end of this year. In the field of third-generation semiconductors, despite the rapid development of China's industrial chain, there are still many shortcomings. High material costs limit the rapid adoption of silicon carbide. First, silicon carbide substrates and epitaxy account for about 70% of the cost of the entire device, and improving the yield of substrates and epitaxy is an effective way to reduce costs. Second, larger-sized silicon carbide substrates are also an important measure to reduce costs. The cost of 6-inch substrate wafers can be reduced by 30% compared with 4-inch wafers, and the cost of 8-inch wafers can be further reduced. Third, the continuous increase in the application scale of silicon carbide can drive down the cost of equipment and materials, thereby driving down the system cost of devices. The good news is that SICC has grown into a global leader in the field of silicon carbide substrates, ranking the top 3 in the world with a market share of 30% in the semi-insulating substrate market. In addition, many other Chinese companies are also developing. The development of downstream industries promotes the progress of upstream industries, as is the case with China's silicon carbide industry. For the shortcomings of the industrial chain, it will take a certain amount of time to break through the bottleneck of materials and technology. However, for the current achievements of Chinese enterprises, the prospects of the silicon carbide industry chain are quite good. Okay, we just spent another 10 minutes of deep thinking. Do you want to know what changes have taken place in the world in these 10 minutes? Please keep following our channel and like our videos.